Good morning, everyone. My name is Silango. I'm assistant professor in the Department of Electrical and Electronics Engineering in Adiman College of Engineering, Hosur. Today, we are going to see about the topic embedded systems for industrial applications. Before that, we have to know about the importance of embedded systems. Embedded systems are essential for enhancing the functionality and efficiency of devices across various sectors, enabling innovations that drives advancement in automations, connectivity and user experience. What is the definition of embedded systems? Embedded systems are specialized computer systems designed to perform dedicated functions or tasks within a larger systems. They are not general purpose computers, but instead of serve specific roles. In an overview, we can say the embedded systems is a combination of hardware and software. A washing machine is a correct example for an embedded systems, right? A machine controls a motor by using the software inside the machine, inside the control board, right? It is known as an embedded systems. Embedded system architecture. The block diagram of embedded system majorly consists of microcontrollers and microprocessors, right? Microcontrollers and microprocessors are the major equipment used in embedded systems for their efficiency and integrated features. Microprocessors are used for more complex systems requiring higher performance. How the microcontrollers, memory, input-output ports and sensors work together. By using the CPU, it coordinates all the RAM, ROM, analog to digital converters, digital to analog converters, input-output ports and communication interfaces like UART, SPI and I2C. The key characteristics of embedded systems. First, in real-time operations, embedded systems often need to process data and response within a defined time limit. For example, an airbag deployment system must be react within millisecond in the event of collisions. Right? An airbag deployment systems in the car. It is a correct example for a real-time applications. At the fraction of second, when an accident occurs or collision occurs, at the fraction of second, the airbag must be released, right? It is a correct example for an embedded systems. Limited resources. Embedded systems often work within strict constraints like limited memory, processing power, and energy consumptions. This requires optimized software and hardware design. Dedicated functionality and embedded systems typically performs one specific task repeatedly. For example, a temperature sensor in a thermostat only measures the control temperatures only measures and control the temperatures, right? It is a specific task. It may be repeatedly doing the same process only. Reliability and efficiency. Many industrial applications requires embedded systems to operate continuously without failures. For example, monitoring critical machineries in factories requires high reliability. Industry applications of embedded systems. Overview of key industries, manufacturing and automation, controlling the machineries, managing factories and operations. Automotive industry, embedded systems in vehicle for safety, diagnostics and efficiency. In healthcare, embedded systems in medical devices like MRI machines and patient monitoring. In energy management systems, smart grids, renewable energy, monitoring and distributions. Embedded systems in modern industry. Embedded systems make industries more efficient by automatic process monitoring systems and improving safety. Applications in manufacturing automations, right? One by one we are going to see now. In applications in manufacturing automation, role in controlling the machinery. Embedded systems are used in programmable logic controllers, PLC, to control the machineries in factories, assembly lines, and other industrial settings. Real-time data collections and processing. Data from sensors like temperature, pressure, or motion detectors are continuously monitoring the data in real time, optimal control and adjustment. For example, PLC and SCADA systems supervisory control are used in embedded systems to monitor and control process at industrial sites. Embedded systems in robotics. Automatically robots in industrial settings, it used as a arms, industrial arms. Industrial robotic arms we are using for specific tasks like welding, assembly, and painting. Embedded systems in role in navigation and control. Embedded systems use algorithm to process inputs from sensors like cameras, ultrasonic sensors, and GPS to navigate the environment. Embedded systems control robots in warehouses, manufacturing plants, and assembly lines. Robots use embedded systems for movement, processing sensors data, and performing tasks automatically. Embedded systems in process control. Monitoring and controlling the industrial process, embedded system plays a crucial role in ensuring consistency and safety in industries like chemical processing, oil refining, and power plants. In HVAC systems, embedded systems control heating, ventilation, and air conditioning to maintain the optimal conditions. In oil refineries, embedded systems helps to monitor the pressure, temperature, and chemical compositions in real time. Embedded systems in automotive industry, advanced driver assistance system, that is called as ADAS. Embedded systems power features like lane departure warning, adaptive cruise control, automatic emergency braking, and self-parking. Vehicle control systems. Embedded systems control engine management like fuel and ignition systems, braking like ABS, and safety features like airbags. In electrical vehicles management system, motor monitoring, battery monitoring, the level of battery charging and discharging, the energy consumptions in electrical vehicle, like that we can used in electrical vehicles management systems. Embedded systems in healthcare, medical devices. Embedded systems are the central to functions of medical devices like pacemakers, insulin pumps, and blood pressure monitors. In patient monitoring and diagnostics, embedded systems are used in devices that monitor vital signs such as ECGs, pulse oximeters, and heart rates and monitors. For example, MRI systems and infusion pumps. MRI systems is used for image processing control, and infusion pumps is used to patient in controlled manner by using the delivering the medications and nutritions on the time. Energy management and smart grids. Roles in energy consumption monitoring. Embedded systems plays a vital role in smart meters. They can track the energy usage in real time and communicate with utility companies for billing and monitoring. In smart grids, real-time data collections and automated responses help to improve the efficiency of the power distribution systems. For example, renewable energy systems that manage the integrations of solar and wind energy into the grid. Smart meters allows the remote monitoring and management of energy usages. Communication systems for industrial IoTs. Industrial IoTs overview. Embedded systems enables devices to communicate with each other and the cloud. Forming the backbone of Industry 4.0, it is called as IoT, Internet of Things. Enabling communications, protocols like Modbus, CAN, and MQTT are used to ensure the reliability in data transfer and remote control of embedded systems. For example, wireless sensor networks. Embedded systems in building automations. In building automation, controlling systems for lighting, heating, and security. In smart building solutions and automated control systems that optimizes energy use and enhance the comfort and security systems, like smart thermostats and security cameras. Challenges in embedded systems for industry. Power consumption. Many embedded systems need to operate in low power environments, especially for battery operating systems. In real-time processing demands, industrial embedded systems often need to make decisions and take actions within the strict time constraint limits. In hardware limitations, memory, processor, input-output capacity can limit their performance of embedded systems. In security constraints, cyber attacks, protecting the embedded systems from the cyber attacks is essential in critical industry applications. Design and development process. First, we have to gather the functional and non-functional requirements, and then we have to select. For hardware design, we have to select the microcontroller, sensors, actuators, and other components for our hardware design. For software design, writing the embedded code usually in C or assembly languages. At last, we can test an integration by using the real world and real applications. Embedded systems for industrial applications. Software tailored for embedded devices often designed to interact directly within the hardware. Real-time operating systems are used to manage tasks in real time, ensuring the timely response to external events. Industrial standards and protocols. There are some protocols and standards used in industries. One by one we can see. In industrial standards ensure that embedded systems meet safety, performance, and interoperability requirements, right? And in communication protocols, the Modbus, CAN bus, and Ethernet are common protocols for industrial customs. In safety standards, ISO and IES for functional safety in industrial environments. Security in industrial embedded systems. Threats. Industrial equipments are targets from cyber attacks. Before the attack, we would take some safety measures, security measures like encryption, authentications, and intrusion detections are critical for securing the embedded systems. One by one, we can see the case studies. Case study number 1, embedded systems in automated factory. Detailed how the embedded systems control a factory's assembly lines or machineries for optimized productions. In case study number 2, embedded systems in smart grids. For example, embedded system monitoring the energy usage and managing the power distributions. Future trends in embedded systems. One, likely we are moving to the AI, right? AI is a tool which is not to replace a human, which is used to enhance a human, right? AI and machine learning. Integration of AI allows embedded systems to make autonomous decisions based on real-time data. Edge computing, processing the data at the edge to reduce the latency and improve the efficiency, right? As we're going to conclude this overview of embedded systems plays an essential for automation, control, and optimizations of industrial process. They are integral to industries like manufacturing, automotive, and energy and healthcare. Thank you.